Howdy folks, I'm Keith Bowen. This is Hard Rock University. As you can see, it's all Christmassy outside and we're having a warm spell. It's up to 20 degrees or something, which is better than it's been. So yesterday I was doing some smelting experiments, and in fact I came up with a bead. Can you see it in there, little one?
No, not really. Try holding it down here.
There it is. Okay.
There we go.
There's a bead. Now that's about 3 millimeters. It's got a little bit of a gold tone to it, but not much. It weighs 0.21 grams, which gives a density of about 15. Now, unless I'm sadly mistaken, there's only one metal that can get much over 11 in density that'll melt at these temperatures. Tungsten will, platinum group is heavier, but none of them will melt. So, and that's gold. So I would say this bead is roughly half gold. And when I was smelting 1 gram of resin, I should have got 0.11 grams of gold. So I'm right in the ballpark where I think I should be here. I'm going to do the same thing I did yesterday with a minor little modification here. Okay, so the first step to recovering the gold is to extract the resin. If we were going to elute it, we could take the resin cartridge probably and put the whole cartridge in the solution and get it out that way. However, we're going to try and flux it. We need to start with recovering the resin, rinsing it a little. Anyhow, so I've emptied the cartridge, I've washed the little, I don't know what you call that, mesh filter out. And now this I can just dry. And then the resin itself pour
Watch
off.
out, you're getting it all over the floor.
Good Lord. Let's pour off the excess water. The resin is denser than water and does a pretty good job of staying in the pan, as you can see. At this point I have to be a little careful. By using deionized water, this step also has done a job of rinsing the resin just a little bit. Oh, I'm doing a pretty good job there. Finally. So now I'll take this resin and put it in the oven. I'm going to try 250 degrees to start with. That should be fine enough for drying, but without driving off the gold. And just as a comparison, let me show you what the resin looked like originally before it got loaded. You can sure see the difference.
Yeah, you certainly can. And we got to clean that water off the floor.
Okay, so let me put that in the oven, we'll get it baking. So here we have the Max Water resin. That's the fresh from the factory on the right. This is loaded on the left. And it's running almost 11% gold. It's a really pretty red color. That may be from colloidal gold or something, I'm not sure. But it's real pretty. And tomorrow I'll see about some simple smelting tests and see if we can start getting some gold out of that in a solid metal form. Here I'm testing a couple different resins from Purolite to see if they're superior to what we're currently using in terms of their ability to grab the gold. So those are going to be running for 4 hours. So duplicating the tests I did with the max water and see what the results come out. Okay, interesting experiment. I was trying to heat some borax to turn it to anhydrous borax. You know, this is just regular washing borax.
20 mil team from Winco.
And I'm just kind of assuming that the surface kind of stuck together and then moisture from within.
Wow, this is bizarre. It's cool, but it's bizarre.
It's some kind of a science project,
Look inside it.
Yeah, I know.
It's really weird in there.
It's bizarre. That's hard too. Huh. Well, you're gonna have to recrush it. Fascinating. Okay. And so here's the first thing. 1 gram of resin. 1 1/4 grams of potassium nitrate, saltpeter. 2 grams of borax. Now, the idea is that the resin has a tendency, when it vaporizes, to send the gold into the vapors. So what I'm doing is I'm putting an oxidizer so we don't need any air movement at all. I'm going to take this. I think I can make this one work. Okay. So I've got the charge. And to prevent stuff from escaping, I'll put another gram of borax on top. So we're at 1 gram of resin, 3 grams of borax, 1 1/2 grams of potassium nitrate. I'm going to take this, put it in this little kiln. We're going to heat it kind of slowly and gently up to temperature. Now, little one, as this comes up to temperature, you'll see smoke. Stay the heck out of the smoke. I also got to turn that fan on.
Okay.
Now, because of the extreme temperatures, these propane torches don't like to work well. So I take cylinders home with me to keep them warm. And then I can take them out, use them, basically swap them out. I brought a fresh set of cylinders from the apartment today. A little more than that, but I want to heat it gently. Notice I've only got 1 torch in there. And I'm going to heat that. And while I'm doing that, I'm going to need to heat this up, because there's still a little bit of what looks like metallic debris there. So I'm just going to sprinkle a little extra borax in here. And that's crazy. Just that little snow that we came in, not in the pan. And there's some other stuff here that I panned out of the flux from yesterday that I'm going to try and heat up and turn into a little bead. I do all my work flooring and such inside secondary containment so that I don't mess it up. Now for this, I need something just a little bit hotter. So I'm going to use oxyacetylene. The little sparkles there, I don't know if you can without glasses on.
No, I can't.
Okay. You might want to put those on. That'll help you.
Oh yeah, I see sparkles.
See that bead there?
Yeah,
Okay.
I see the bead. I
There's-
don't think it's going to show until you take the flame out of the way, but I may be able to get a shot when you take the flame out of the way.
Yeah, that round thing is a bead. And what I'm going to do now is I'm going to work that bead around this whole thing, trying to pick up any little pieces of metal. Yeah, it's a little hot. Start sparking like that, stop, take the heat off it. Do you see those little beads down there?
Yeah, I can. They're not showing it all in the video, but I
I
can.
wouldn't think so. Okay. So the bead's now in there. Now if you take a look inside the furnace, can you see that the flux is increased in elevation?
Yeah.
Yeah, it does that.
Yeah, like
melt
it did in the oven.
Yep. Now I'm gonna melt it down a little bit here. Keep from doing that. And now I'm gonna put the other torch in the circuit. Really start heating that up. Okay, you can turn that off now. If you look in there, that's about as hot as it's going to get at these temperatures. Okay, the propane just doesn't have anything more than that to give. So, we can add a little bit more heat by doing this. Now, this is kind of hard on the crucibles. You can also turn it to pure oxygen and get an oxygen-rich environment in there. And again, you can see the temperature is coming up. Getting hotter and hotter. We're now at an orange from a dull red, probably about 1600. And that is just, let's say, we're heating it up. By now the resin has pretty well decomposed and there's no more organics in there. But now we're trying to dissolve the various metals and react them with the flux. You can hardly see with that darn. Now this was a brand new crucible. See how much that has eaten it out already? Sparks of light in there. I think those are the residue of the resin beads. I think those are little balls of metal. And flame hits them, melt and react.
It looks very pretty in my glasses.
I'm going to try and shake it so that all those little balls kind of come together. Now this will work a lot better with a much better furnace and just giving it some time. But we want to make sure that it was going to work before we did that.
Yeah, I don't like that smoke coming off it.
Yeah, well, it's blowing away from me. Are you okay?
Yeah, at the moment.
Okay.
I'm watching.
Now what I'm going to do is I'm going to pour off a little bit of the extra flux. Now, I'm surprised I'm not seeing a bead right now. This is when I saw the other bead. Don't see a bead in there.
I don't either.
I don't know what's going on. It may be in that slag that I dumped. Yeah, those carbon crucibles don't like an oxygen-enriched environment. More like, I'm pretty sure that's aluminum oxide dish right there. The other possibility is Fireplay. Well, now that things have had a little chance to cool, the flux from there that I dumped out, crushed it. Here's a little bead right there, and there's quite a few little beads of gold in there, but I didn't get the bead like I did yesterday, that nice big single one like this. So we still have to do a lot, but I think my biggest problem is just getting a high enough temperature to where everything just flows and keeps flowing. So,
Silly question.
what?
Do you think that getting a high enough temperature without shaking things around or blowing on it to move things apart would make it coalesce easier?
Probably. Actually, a little vibration probably wouldn't hurt, but we need a furnace. Okay, this thing right here ain't cutting it. Might work with MAP gas. It doesn't work with propane, and these crucibles just can't handle the heat when you start putting in oxygen. So we need to get a better heating system. And I've got some cupels on the way. I'll need to get some actual small crucibles, and then we can play a little bit better games. But that's our problem right now, is that I just can't get a high enough temp and keep a high enough temp. It should be glowing almost white hot, okay? And it's only doing that in part. Only where the flame is hitting it. The whole thing should be glowing white hot, practically. So anyhow, we're making progress here, and I think the basic concept works fine. I mean, I can even see from here, there's a little piece of gold right there. I don't know if it's visible in the thing or not. Just right there at the tip of my finger is a piece of gold. It's almost like, you know, what flower gold wizards would normally see, but there's a number of them in there, and we're still working on the final formula, etc., but right now heat's killing us. Or actually cold. I don't know. Lack of heat. So, happy prospecting and keep it safe out there.